Hey everybody, good afternoon and welcome here. Hope you all had a good lunch. If you haven't yet already, as you're waiting for us to jump into the check-in, please make go to Google Classroom, open up the copy of today's slides. Today we're on day 9. That's where we're at. Um, by the way, I think yesterday I had not linked to day 8. Double check. I should have day 8 and day 9 linked up on Google Classroom for you to follow along with me today. Thank you all so much for being here. Let's go ahead and jump into our check-in. Um, cool. Let's see, what's today's check-in? All right, so as you all know, today's your last content day of classes. So content means like your content classes. Tomorrow you do have advisory, right? But it's something to look forward to. I think this is your last class of the day. So a question I have for you is, what do you look forward to during spring break? So what are you looking forward to doing next week? Go ahead and put that into the chat, and then I'll go ahead and record attendance for us. Okay, I got 2 saying sleep. One in the direct message, more sleep. We got sleep and some binging on some shows. I am all for that, especially sleep. I don't know y'all, but I've been feeling like I've been overworking this week. So I definitely want some extra sleep and catching up. All right, we're all looking forward to sleep there in the chat. Okay, someone's looking forward to homework. Okay. Oh, wow. Okay, birthday coming up. Birthday, hotel party. Wow, my trip where I get to bring 3 people with me. Dude, Jasmine, that's awesome. And is your birthday today or is it going to be next week? If so, happy pre-birthday. I think there's a special way to say it. Yeah, happy pre-birthday if I miss it on the day of. All right, we have actually going out. I am with that too. Like, I feel like I at least need to go out since the sun is out more and it's not as hot as summer. There's a bit of wind. I don't know. The weather seems nice. So it's nice to kind of go out. I still have to put on a jacket though. Awesome, awesome. Those are some great plans I see so far. What other plans do we have going on here for next weekend, or what are we looking forward to? We're almost there. Welcome, welcome. Getting a few more folks in here. Hi, y'all. For those that just came in, we're answering this check-in question. As you all may know, next week is spring break. Hopefully you knew that. But what are you looking forward to next week, knowing that it's spring break coming up for us? Go ahead and put that into the chat so I could see who just came in as well. That will help me out a lot. Looking forward to anything. I like that. Someone last period was like, looking forward to not logging into Zoom, which I can totally feel. Yes. We've got complete my missing assignments if I have some. Okay, so looking forward of getting some stuff kind of like out the way. I could totally see that as well. Thank you so much. Again, if you just came in, if we could answer this check-in question for us so that I can mark you present. And then y'all can correct me if I'm wrong to see who we're missing here. All right, let me go ahead and see who we're missing, and y'all please correct me if I'm wrong. Just making sure I got everyone that answered there in the chat. So I'm missing Shema, Kalia, Justin, Dior, Jayla, Ernesto, Anna, Jose, Jonathan, Amara, Cassie, and Sakaya. So double check me if I'm wrong on that, but I'm gonna go ahead and do another run through. So if you're friends with any of these folks, if you could please, send them a text to come on into class. We do have today some in-class credit. Here we go. So I'm missing Shema, Kalia, Justin, Dior, Jayla, Ernesto, Anna, Jose, Jonathan, Amara, Cassie, and Sakaya. Guys, I appreciate. Oh, we just got Jose, y'all. Otherwise, y'all, I appreciate you so much for being here. So we could get a good day of learning going on. Oh, we also got Anna, everyone. This is great. Getting more folks coming in. And we got Shema. Welcome everyone who just came in. We just did our check-in, basically just checking in on what we have, what we're anticipating and looking forward to. Next week is spring break. We're almost there, everyone. Okay. Thank you so much, y'all. Let's go ahead and jump into today's stuff. Here's our agenda. So I just took attendance. We're gonna go ahead and finally take a look at that Google form that we did not have time for yesterday. It is important for us to kind of check our understanding of that lesson I did yesterday and like how to create an equation with a wave. So that's how we're gonna start off today after a little recap. Then finally, I have the big ideas packet up and ready for y'all to look at. I was actually working on it this whole module. I was working on it with another teacher at the other school, trying to make it better, make it accurate. So yeah, we're gonna finally do that and look at it. We're gonna do a whole class annotation of it. Then hopefully we'll see if we get a chance to talk about the mini final. Part one of the mini final was due last night. There's still opportunity for you to turn in a draft of that. Part two, the due date for that, for the draft, right, is coming up tomorrow at midnight. So basically, again, drafts. So you're not supposed to worry about it being proficient. We're gonna fix our work when we come back from spring break. So right now, just turn in a draft. Try to turn in like your best try at this. And again, when we come back from break, we'll work on making it proficient. Let me know if anyone has any questions about anything happening today or about the mini final. I'll just pause here for a bit. All right, y'all, thank you. I quickly responded to 3 individual questions. Go ahead and check your private chats for those I responded to. Let's go ahead and jump into our recap, everyone. So yesterday we talked about how to actually create an equation looking at a wave. So for example, this one right here was a sine equation and it had parameters A, B, C, and D. And basically our goal was we needed to solve for whatever A, B, C, or D was. And we went through the steps. Here was finding A, this was finding B, C was over here, that's our horizontal shift, and then there's D, and then we plugged it in and got our equation. Other important things you should know is when before we even started doing this, I had to like pretend I had this out, like kind of if I was working on a table, I had to look back at the parent function for sine, and then I had to look at the formulas I was given. And here, all this work you see here is me applying the formulas. So that is what we did yesterday. And we didn't have time for the Google form, but y'all had like a lot of great questions when I did this example yesterday. Not only that, but of course, yesterday we went over important definitions you should know to be able to create these models of waves. So these are some important definitions. Period is the length of a cycle. As a reminder, you measure the period by counting the distance from peak to peak, or you could think of this as counting the distance from maximum to maximum. Amplitude is the distance from the midline to a peak. We have phase shift, that's the side to side shift from the usual position. Vertical shift, if your wave moves up or down from its original. And then midline is that horizontal line that passes in the middle between the wave's maximum and minimum point. So those were like important definitions for y'all to be able to access these problems and understand what we're doing when we're using these words. So that's a little quick recap. Again, feel free to add in any questions. You can unmute or use the chat, and I'm happy to address them before we jump into the first credit today, which is our Google form. So we could try to apply what we did the other day into this form. Okay, cool. Let's jump into it, everyone. So I'm moving on to, oh, sorry, this is period one. So ignore this. I had to, period one is at a different location. So if you're following along with me on the slides, we're going to be jumping to slide 8. So period one had a different thing. So let's go to slide 8. If you're following along with me, again, slides are on Google Classroom, and we're going to be doing the Google form. And I encourage you to just try your best on it. Um, Period one and me had like a discussion on what was really confusing, and there was a lot of confusing parts to it. And it was great because then we got to kind of like address what was confusing and kind of talk about what talk about that. So again, they had a different process. But in order for me to know what's confusing when it comes to you all, is you have to first try it. So that's why I want us to all go ahead and jump on this Google form. This is today's first credit. And we're going to go ahead and try to create an equation that models this sine wave right here. So you're going to try to create an equation for the sine wave. When you put your answer, if you could try your best to kind of explain what you did, that would help like kind of us see like what everyone else is doing. Don't worry, it's going to be anonymous if I show anything. All right, does anyone have any questions of what we're going to be doing for this next 10 minutes? All right. If there's no questions, I went ahead and I put the directions in the chat. So yes, you want to make sure you try your best, turn it in. You'll get an A if you do that, and it's okay if you don't know. So it's okay if you have questions. Just try your best on it. And what I recommend is you could look back at yesterday's slides. So day 8 was when we actually did the steps. Or if you look at slide number 4, basically you have to click present to actually see the first picture. So I click present, and then this is example 1 from yesterday. So you could also look at this as you complete your form to kind of best create the equation based on the example we did yesterday. Okay, so those are my tips, everyone. I'm gonna go ahead and get you all started. So let me start a timer. Let's be back in 10 minutes, y'all. See you soon. Everyone, about 7 more minutes until we check in. So I also just updated today's slides. So on today's slides, day 4, if you check it out, I went ahead and I made sure that example 1 was in the front so you could easily access that example from yesterday. Everyone, I see that there's a few more coming in. So let me go ahead and give one more minute and then let's come back and we'll look at trends and patterns and let's talk about it. One more minute, y'all. Okay, everyone, welcome back. Sorry, I stopped my share so that I can go to the Google form. So let's take a look. Okay, y'all, thank you so much. Now, if you're still actually typing out your response, please go ahead and do that. But so far we have 10. So I mean, please, some of you are still working on this. I think 7 more students are still working on this. Make sure you get this in. But for now, I'm going to go ahead and take a look at the trends and patterns that I'm seeing as far as the answers are concerned. So let's do this. Okay, so let's take a look at what we're seeing here. A common theme that I'm seeing, or a trend, let me go ahead and circle. Okay, common theme that I am seeing is the A, the amplitude. This is this person, the student got 1, the student got -5. I wouldn't know if this is amplitude. This is missing the sign portion of it. This student got 0.5. A little bit confusion here, and that's okay. Appreciate the honesty. This student got 1. This one got 5, but they used a tangent. So that's interesting. So tangent usually looks like this, the parent function for tangent. Something like that. It's hard for me to draw, but tangent basically is not a wave. But we could totally switch this to either a sine or cosine, and you will get like a wave sort of pattern. So just a little note for the tangent right there. So that's my first notice. I noticed that the amplitudes are different. So that shows me that we need to talk a little bit more about amplitude. If I scroll more a little bit down, again, there's students who are perhaps not adding in like whether it's a sine or cosine that they're modeling, but because this is a wave, you want to make sure that you add in a sine or cosine so that you tell me that you know that sine or cosines are functions that model waves. So that's just feedback for those who did not include a sine or like, cosine. Okay, so here it's cool because we have a little explanation going on here. So y'all free to read that. So this student says they got 0.5 because they saw the maximum and minimum was -4.5 and -5.5. So what they did is they divided by 2 and they got 0.5. So that's why this student got 0.5, they said, as their as that first term right here. And then I got 0.5 by getting the period length as 4 pi. And then they used an equation. So I see a reference to our equations that we mentioned in our recap. And they did everything and then simplified. And that's how they got this second 0.5 right here. Then they said the phase shift is 0 because they didn't see that function move horizontally. Vertical shift I got was -5 because it starts at -5 when x is 0. So I just liked it because it has a little bit of an explanation. We have a few of us who are like, probably a little bit stuck. So a few of us are guessing, a few of us need some support. So that's good for me to know. So let's go ahead and talk about what the solution to this problem is. Again, one of the trends I noticed was the A. Another trend I'm noticing is the D actually. So before we move on, so this is the D term right here. A common trend I'm seeing is the -5. So I'm feeling like, and or either -5 or there's a +5. So I'm feeling like we understand in general, kind of like what is that D, right? The D is basically representing vertical shift of the function. So, but even if we have like a good understanding, I do want to address, is it -5 or is it +5? Which one's correct? Then lastly, of course, I forgot, but another trend is I see 4 constantly popping up here in front of the X, either 4.4, 4 pi, different various numbers for what that B term would represent. So those are the trends that I'm seeing, and let's go ahead and talk about them. Let me clear up my screen. Let me know if there's anything anyone needs me to point out and add, if you see some other kind of trend happening. But that is just my quick look at any trends I'm seeing. And again, please make sure you enter in your response for your credit here today, so I could give you some credit, my friends. Okay, cool. I'm gonna go ahead and shift us back into our slides so we could discuss this problem. On our slides, I'm going to slide number 9. And we're gonna do this together. And I'll try my best to color code it. For today's round, I did not already create the steps. I decided I'm just gonna use my annotation tools and just start to write everything down. Okay, y'all, let's do this. So step 1, before I even start anything, what I'm gonna do is I'm gonna draw the midline of this function. So remember, the midline cuts my wave horizontally in half, right in the middle. So I'm gonna go ahead and draw that. So this is my midline. I can't see because my bar's in the way. So I hope I did this straight. I can't see. Yeah. Oh no, this got crooked. Can't see well. Let me fix it. Let's see if, okay, I think I know what to do. Oh, that didn't really help. Okay, I'll try my best. So again, I'm trying to cut this directly in half. It's just hard for me because the bar is in the way on this side. Okay, I think I did it. That is my midline. So as you can see, I cut it directly horizontally in half. So we have even pieces on each side. That's called my midline. And the reason why I drew this midline, it's going to help us find both the amplitude and also D, the vertical shift. Okay, let me get my tool again. All right, so our goal is we want to find the amplitude. So I'm doing this one first. And that's basically my A term. So for those of you who did a tangent, right, you wrote tangent, what we're looking for is we're actually given sine. So we know that this is a sine function. Another way you know this is a sine function is because it's a wave. So you want to make sure that you understand why it's a sine. It could have also been cosine, but this is a sine function. So you want to make sure that you adjust that response when you can. Okay, so let's find the A term. So how we find the amplitude is you basically count from the midline to a peak. So from this midline to a peak, the distance. So like, what is this distance? You could have also done it over here. This right here is from the midline to the peak, the distance. And let's go ahead and figure this out. So I could see that this down here, the midline is intersecting the y-axis at -5. And then it goes like up a bit. And this looks like it's about -5.5. Sorry, -4.5. My bad, we're going backwards. And then you got -4. So the distance from -5 to -4.5 is going to be 0.5 or 1/2, whatever works for y'all. See how I got my amplitude, everyone? And there was a lot of different responses for amplitude as we looked in the form. So let's first check, do we understand how right now we got that the amplitude is 0.5? That's my A. And let me write my steps in green. First, we drew the midline. Then we counted the distance from the midline to a peak. So that is what we did to find amplitude. So yeah, so I'll just pause for any questions if they're coming up for anyone. If not, we're going to move on to the B part. So we're now moving on to finding the B term right here. Okay, cool. So in order to find the B term, so moving on to this blue term right here, I'm going to take a look at my formulas. Here in the formula, it says that the period is 2 pi divided by the absolute value of B. So I'm going to go ahead and go to the side and kind of just write down that equation. So the period is equal to 2 pi over B, absolute value of B. And remember, everyone, our goal is I need to figure out what B is. And B is right here. But in order to figure out what B is, I think I need to define what my period is for this particular function. So I need to know what this is. Luckily for us, we've had some practice on how to find the period of a wavy-like function like this. And the process for finding the period is you identify two maximums, or basically two peaks. And what you do is you find the distance between those peaks. You go back to your x-axis, use it as a ruler, and that's going to tell you what the period length is. So I'm going to actually choose these two as my peaks. So right here, just because they're both kind of on the positive side on x. And I'm going to delete my amplitude work, y'all. Just delete this so that I have space to see. And basically what we do is once we've identified two maximums, I'm going to draw a line that connects them. My goal is I need to find the length of that line. Like, what is that length of that line? So in order to determine the length, what I find easy to do when you have a grid like this is I count how many boxes it takes to get from one peak to the other. So I'm going to do that. So I'm going to go 1 box, 2, 3, 4, 5, 6, 7, 8. So it took 8 boxes to get from one peak to the other. You could even check the others, but it would be the same thing because they're regular in their separation. So what do 8 boxes represent? Well, that's when you use your x-axis as a ruler. And what you're going to do is you're going to count 8 boxes and figure out the length of this to give us the period. So 1, 2, 3, 4, 5, 6, 7, 8. I land on 4 pi, so my period has a length of 4 pi. Let me know if anyone has any questions on how I found the period. Let me also just put my instructions here too. So to find the period, this is what we did. We counted the distance between two maximums. And used the x-axis as a ruler. So that is what we did here to find the period. Okay, cool. I don't see anything in the chat, so let me go ahead and go back to my original problem. I need to figure out what this B term is. So what I found so far is P. I know that the P is 4 pi. So what that means is, you see this P over here? I could substitute, because I know that P is 4 pi, so I'm going to substitute 4 pi. And I'm going to set that equal to 2 pi over B. There's my setup. And as you remember, there's a particular way you go about solving an equation that looks like this. And one of them I mentioned was yesterday, was that we can do something called cross multiplication. You have to put this over 1. And once you do that, you are able to cross multiply. That's how we get to kind of free up that B and be able to solve for it. So when we cross multiply right here, you should get 4 pi times B. And then on this side, we have 1 times 2 pi. So 1 times 2 pi is simply 2 pi. And then I'll pause to see if there's any questions about what I just did right now. Now, from yesterday's step, let me see, does anyone know like what I do next? I want to solve for B. What should I do next? And I did this step yesterday, if anyone remembers. What should I do to both sides to solve for B? Okay, yes, I got two responses here in the direct and one public. Yes, you are all correct. Divide both sides. That is right, y'all. And specifically, someone in the direct message said divide 4 pi on both sides. You are right. That is exactly what we're gonna do, and we're gonna be able to free up that B. We're gonna set it free, and it'll have some value attached to it. Yay, we're almost done the solving for B. This goes away. My B is gonna be free. I'm just making sure I'm color coding this for y'all so y'all can follow along with me. So the absolute value of B ends up becoming, well, pi divided by pi, because these two are the same, the pi's cancel out. And what we have is 2 divided by 4 left over. 2 divided by 4, if you all reduce that, is 1/2. Or you could say 0.5, whichever works. And remember, y'all, the absolute value of B basically just makes whatever numbers inside there positive. So we could simply say that B is either just 1/2 or 0.5. I'm just going to say it's 1/2 because I prefer the fraction. So there's our B. I'm going to go ahead and go up and write that in for my B. So B is 1/2. Well, it doesn't make sense because I said 0.5 for A. So I'm going to actually just say 0.5 then for B, just to keep it the same. So whatever. B is 0.5. I shouldn't scratch that. Hold on. There. Okay, so we got B is 0.5. Does anyone have any questions on how we solve for B right here? Let us know, and I'm happy to explain that. Okay, cool. Now, y'all, let's move on to C term right here. So C, phase shift, because C is found in the phase shift. So let's check this out. Well, first off, to determine phase shift, we have to first determine whether or not this sine function moved horizontally side to side. That's what it means. So in order to kind of check this, I'm going to go back and look at my parent function right here. So this is the parent function for sine. Sine starts at 0, 0. If there is any horizontal shift, then the x value would start at a different spot. Let's check. So I'm going to go down here. This is where the sine function starts. And this particularly starts at 0, -5. The y value is going to be different, but the x value is still 0. That means this function did not shift at all horizontally. So the phase shift, or C, is 0. There is no shift. So x is still 0 means there is no shift. Let me type that out. Because the x value is still 0, at the starting location, we have no shift. So C is equal to 0. So that's exactly my reasoning right there. Let me know if anyone has questions about that part and how we got that C is 0. Now we have the final last thing, that D term. Remember, when we looked back at the form, half of you said it was +5, and then half of you said it was -5. So let's see who got this. Oh, there's something in the chat. Oh, is the graph on the left corner always going to be referenced to determine the C term? Yes, that is a good question. Yes. In order for me to know whether or not we have a shift, you want to look at the parent function. And that graph in the upper left is the parent function for sine. If you were asked to create a cosine function, the cosine function starts at a different spot. So you would have to reference cosine. So yes, we do always need to look at the parent function to look at if we have a shift or not. That, or you have it memorized where your sine starts. That's another way too. Cool, thank you for the question. Let me know if there's any more. Okay, so I have another one. How do you know if it's shifted? It's a good question. So right here, kind of put it there here, but because the x value is still 0 at the starting location, we have no shift. So how to tell if it's shifted is when the starting value for x is not 0 for sine. So how do I know if it's shifted? Let me just write down that question. When the starting x value is not 0 for sine, then you have a sideways shift, which is your horizontal shift or your C term. There's a little typo in what I wrote, but how do I know if it's shifted was the question. And it's when the starting value for x is not 0. That's how we know we have a shift. Because right here, if you see I put a little arrow, the starting value for x was still 0. That means this did not shift side to side. Because if you look at the parent function, the x value started at 0. We're just looking at the x when we're talking about sideways shift. Great questions, y'all. Okay, y'all ready to tackle what D would be? Again, the disagreement was like 50-50. Either it was -5 or +5. So let's talk about vertical shift. By the way, we're not doing frequency here, but it does come up in your mini final. Again, you just want to try your best, just like y'all did in the Google form. You just give it a try and then we talk about it. When y'all come back from spring break, we'll try to work towards proficiency on the mini final. But yes, what is that D term? So basically, y'all, the D term is where your midline intersects the y-axis. That is your D. So y'all, when I drew this line right here, that's my midline. It intersects at the y value -5. So y'all, the vertical shift is -5. I am interested to know of those who got +5 though, but the answer is here -5. And let me type out y just to make sure that we all understand. It's where the midline intersects the y-axis. And now that we know A, B, C, and D, we're ready to create the equation for this. So that's going to be, here's the answer down here. It's going to be y equals 0.5 sine of 0.5 x. So, and then it was plus 0. C is 0, but we don't need to write plus 0. You could if you want, but you don't have to. But I'll just write it for the sake of those who might be confused. And my d was minus 5. And then how you would simplify this is you would just not have to add the plus 0. So I think that student that had the explanation written down had it correct. So that's awesome. An x minus 5. So here is our answer for how to model this wave. Yes, that was a workout, y'all. So let's see if there's any burning questions or last minute questions for this before we move on to the next thing. The next thing is going to be our checkout, everyone. Our checkout is going to be on the Big Ideas packet, by the way. So we'll be able to open that and take a look. Okay, cool. I'm also going to make sure I send the recording to this today so y'all can use this to help you out in the mini final when you're being asked to create an equation for your sound wave. By the way, it's so exciting to see the different sounds y'all are submitting. Let me clear my drawings and let me guide you to where I'm going now in my slides. So very quickly, before we do our checkout, I just wanted to share with you all on slide number 12, the different unique sample sounds that people are actually submitting and making waves for. So let me share with you this one. This person, oh, did y'all hear that? This person did a whistle and they had a very nice looking graph. Let me do one more and then y'all are free to check out the other ones. So this student has a dang guitar, so they're making great periodic waves with that guitar. Again, you feel free to take a look at the other samples. I was really excited to share the different variety of sounds y'all are trying to analyze. But yeah, so I'm gonna go ahead and take us to slide number 10, y'all, for our checkout. Our checkout is not gonna be 5 minutes, but it is the same thing. I'm gonna open up and share with you the Big Ideas packet. You're gonna leave one comment as a question or rephrasing your understanding. You can comment on another student's comment if you know the answer to their question. And yes, you could comment more than once. We're gonna all just use this same resource. So you don't have to make your own copy actually. You're just gonna write on this Big Ideas packet together. So go ahead and open this up. This is our checkout today, y'all. This is the last thing we're gonna be doing. But first let me wait for y'all to get on the document. It's still loading for me, so okay, cool. I see 4 people on the document. Awesome. Remember our checkout today, 5 people now, is to just make one comment. So you're just gonna go down, make a comment. We have about 3 minutes. If you need more time, go ahead. I'll be entering in today's credit later on today. Here you can see some of period 1's comments. So if you know anything, an answer to their question, or if you agree with them, feel free to you could comment to their comment as well as a checkout. Let me know if anyone has any questions about what we're doing here for a checkout today. Great, and we have about 11 total viewers on the document. Make sure we get on there. Yes. So I see an anonymous goose. I see a theory. I see Jazane, Jimena, Jose on the doc. I see Crystal, Natalie, Shaylin. We got Kevin, Anna, and Shema. Y'all are awesome. If I didn't say your name, come on into this document and make your comment. All right, everyone, I'm gonna go ahead and let you all comment and I'll bring us back really soon in about a minute-ish. But if you don't have time to make your comment in about a minute-ish, don't worry. I'll let you do that. I'll enter then these grades by the evening today, so you'll have some time there. All right, everyone, I'm going to go ahead and bring everyone back. Again, do make sure you enter in your last little comment there, but I totally understand if you're still reading through this big ideas packet and you need time to process. So I'll be checking in later this evening. All right, everyone, y'all have just advisory tomorrow. Then we have spring break. Yay. I hope y'all get to relax. But yeah, I'm going to go ahead and end this meeting. Bye, everyone. See ya and enjoy your break.
Mrs. Ronald,
Yeah, what's up?
I have a question
Yes, go ahead. Bye,
about
everyone.
the mini final.
Mhm.
Hold on.
Yeah, of course.
Okay. You know, in part 2,
Mhm.
it says to create a triangle function.
Trigonometric function.
Yeah. Is that with the sine thing?
Yeah.
Or
Sine or cosine actually will work. Sine or cosine are the only ones that will give you a wave. And did your sound look like a wave?
yeah.
Yeah, perfect. So you want to use either sine or cosine, just like kind of what we were doing here. You know,
Uh-huh.
when I went over like how to create your equation, that's
Uh-huh.
exactly what you're going to be doing, but you're going to be analyzing your sound wave.
Oh, so the one that you're showing right now, that's the steps.
Yeah, those are the steps to help support you in creating your equation. That's right. And then once you do that, you want to check your work by putting your equation on Desmos and seeing if it matches up with the sound wave that you made.
Oh, okay, okay.
Yes. Yeah. And then let me know. I mean, feel free to text me and remind or let me know on an email, if you want me to check or give you feedback as well too.
Okay, because I was getting a little confused because it was first because I saw the first one on the
My video,
no big the
big
big
ideas,
yes. So then I was looking at big idea number 8. No,
go to it. Big idea
7. It was a
7.
7. So then it was saying the triangle thing function.
Yeah, trigonometric
So
function.
then I don't know how to do it. So I thought I'm like maybe I have to do how 8. That's how I figured it out. But I just wanted to make sure.
No, no, it's perfect. So this right here is just showing you different kinds of functions that are periodic.
Mhm.
That's saying only functions A, sorry, only functions A and C are periodic. So A, this one,
Mhm.
C, because these both are repeating, but then
Mhm.
B and D are not periodic because they're changing. Like they have the same pattern to it, but they're like changing their height, so they're not periodic. Same like this one. So these two are periodic, but no, you're not gonna do something like A. So you're gonna do more like something like C, which is
Okay.
like sine or cosine.
Uh-huh.
This is more for like kind of complex kind of idea.
Uh-huh.
If you're interested, like if someone made a sound wave that looks like this, then they probably want to look at that. But if yours looks like this, like a wave, you're gonna use
Mhm.
sine or cosine.
Okay.
Yeah, that's a great question. Oh, and you had this question, right?
Yeah.
Yes, these are the trig functions. Oh, that's the one you're asking. Yes,
Yeah.
that is that these are some of the trig functions. Like all of them, there's like six or seven trig functions. If you want to include tangent, there's also the other ones, the reciprocals. There's also the inverse ones. But for this one, for our mini final, you can use either sine or a cosine wave.
Okay. And then to make sure you have the right numbers when you're making the little graph,
Yes.
can you still do like the little graph thing? Or how can you like make sure you're doing the right thing?
Yeah, how can you make sure by so first once you try to solve for your sound wave, right? Like you try to find A, B, C, D for your
Uh-huh.
wave, you're gonna go to Desmos and plug it in. Like you're gonna go ahead and just write the equation down with your A, B, C, D plugged in, and then you're gonna check if it matches. If it doesn't match, that means there's probably a little error, and that's what you want to fix. So that's how you could check your work for the mini final specifically.
Yeah, because I was having a hard time putting it. You know where you told us to put it in the one you have to what's it called? Uh, the graph to show us
The what?
the graph. Hold on.
Mhm.
That one. Oh, the one we put the sound
Okay, the one where we put the sound. Uh-huh.
on the mini final.
Yes.
Um,
Let's see. Should I open it? Should I open the menu final?
yeah, so
Okay.
it will make more sense for you.
Okay. That makes okay. Totally. Let me do that. So we're period 3. And I'm gonna open up mini final for the part 1. Let me see if I could look on your document because you turned it in right here.
Yeah.
And okay, so which one?
That thing right on two.
Number 2, this one?
Yeah. So we're trying to do that one. How can I make it like what's it called? Um, with the graph you were showing us,
Right.
because it was hard for me to figure out like the numbers.
Which numbers?
With the oh my gosh.
Let me make this big. Like should I do you want me to play your sound? I just don't know if it's gonna give the same graph that you got though. I could try to play your sound and see what you mean when you say numbers. Do you would you want me to?
Yeah,
Okay. What sound did you play?
I think it was E.
Okay, that's a good one. I sucked with E. My E did not make a nice. Oops. Let me try to get in my best. So I have to do this quickly. Okay, move this up. So I have to click. Okay, it's this one. Okay. So I'm gonna play it and I have to quickly. Darn it. I didn't get the same thing you did. Okay, let me try again. Oops. Oh, I was late. It's hard. I don't know how you got that nice picture. Okay, let me. Yeah, I was late in playing it. Once more, let me do this. No, darn, I saw a good wave in there. Okay, wait. You try pretending like you're doing the E again.
E.
You try it, and I'll try my best to stop it. Oops. Okay. Try it, and I'll try my best to stop it. Like, you had a very nice wave. Okay.
E. Oh no. E. E.
Oh shoot, it was almost there. Okay, go ahead.
E.
Oh
E.
darn, that was almost there. Okay. Oops. Sorry. Sorry, we're trying this so many times. I seen the nice wave popping up. Okay.
E. Oh. E.
Almost. Okay, so let's just pretend this was your graph.
Yeah.
Okay. So let's just pretend. So when you're saying, are you saying it's hard to see like these numbers, like when you're measuring
The bottom ones.
these ones,
Yeah.
milliseconds?
Yeah.
Yeah, because it says time in milliseconds. So that's why it was hard because it's like when I push it, it's like it's going so fast. They're measuring in milliseconds, like 0.000 of a second. That's why it's so.
Uh-huh.
But did you use this measure tool right here? Do you see this little box?
Yeah, I did.
Okay. So that's usually like and what you had to do is you go from peak to peak because remember that's how we measure the period length.
Mhm.
And I got about 3.88. You obviously got something different because you got it at a good moment.
Mhm.
So you got 4.0048. Close. I got 3.8. So our
But it
number,
was like 3, because I converted into seconds.
yeah, let me.
It was 3, 20 something.
Oh, I see it right here. Hold on. You put this. So 0.0048. Um, so I feel like you did it correctly because I'm getting something kind of close to that.
Mhm.
And then you converted this to seconds.
Mhm.
Awesome. I mean, so far it looks good. The only thing you're probably missing is if you wanna add that this is so you put sine wave and cosine wave. Um,
Mhm.
you want to choose one. So do you want to choose this to be a sine or do you want to choose this to be a cosine? It's up to you.
Sign.
Okay, so you want to choose one and then you want to describe how did you get this. So again, you want to say you used the
Oh.
measuring tool,
Mhm.
then you converted the milliseconds to seconds, and then from there, I want to know how you got 208 hertz. Like what steps did you do to find that?
Okay.
And then okay, and then you had this right here. Do you have any questions about this or were you mostly just about number 2?
It was just number 2.
Okay, because we could totally still talk about this after we come back from spring break, or if you want me to, I'll look at it. I'll
Mhm.
return it to you after making some comments too as well.
So basically, when you're doing the little graph of cosine and what-
Or
sin
some,
and cosine, basically the graph is the numbers that is the one that you show us, or
yeah, like for example here, your A term you got a 3. Your
Uh-huh.
B term, you got 1. Your C, you got 0. And your D, you got 3. You want to definitely first off, like, oh yeah, I see how I see that you're trying out the steps.
Uh-huh.
So you want to definitely kind of explain, like, for example, if you got an amplitude of 3, let me zoom in to your picture. So if I look at this, I don't see an amplitude of 3 actually. So let me show
Mhm.
you. Let me just pretend I'm doing the steps I did in class. So I'm going to step 1. To find the amplitude, you draw your midline. We're going to have to approximate the midline. It has to be somewhere in the middle. I feel like that's not in the middle. Try again. It's hard. Do you think that looks like the middle?
Yeah, I think so.
Okay. And then if I look at my scaling, this is 0.1. Oops. Up here. Okay, let me undo that. This is 0.1. And all the way up here we have 0.2. So this starts, where would we say this starts? I would say this starts like at,
See, that part I was confused. I
yeah,
was like, because I was having a hard time finding
yeah,
it.
zero, like it looks kind of halfway between, right? From 0 and 0.1. So maybe we just need to find out what's half of this distance. So I'm going to go ahead and do 0.1 divided by 2 on my calculator to see what we get. 0.1 divided by 2, so half of that. So this is 0.05. You could double check if you get the same number.
I get 1.05.
1.05. Okay, what did you divide?
Let's divide 2.1.
You want to divide 0.1, this right here.
Oh, it's 0?
Yeah, that's a 0.
Oh,
Very tiny. I had to zoom in, but this is 0.1.
divided
And
by 2?
we divided by 2 because I'm trying to figure out where this midline is at on the y-axis.
Uh-huh.
And we're dividing by 2 because it's in between 0 and 0.1. It's halfway between. So then in
Mm-hmm.
order to find out where that's at, we take 0.1 and divide it by 2 to find out where this is at.
I get 0.5.
Like this one, 0.05.
Uh-uh.
You got 0.5? Let me try again.
Yeah.
So 0.1 divided by 2. I got
Oh,
point.
yeah. I did it wrong.
Oh, okay. So a 0.05, right?
Mm-hmm.
Okay, so that's where my midline is at. So do you remember in class what do we have to do next to find the amplitude, the A term?
Oh, you have to do it from the point thing, right?
Yeah, like you have to first find where it's like a maximum.
Uh-huh.
I like this one because it's more smooth. So and you basically measure the distance from the midline to that maximum. So we have to figure out this distance. We could also like estimate it. So first off, we have to figure out like what is this height, and we can make an estimate. So this is 0.2. What would you estimate this is? Zero
Two? No. 0? No.
has to be a number that's close to 0.2, but less than it, if that makes sense. 0.8,
1?
because this is 0.1. It's down here. Um, so I was saying we could say it's 0.18 because this number is close to 0.2. Like if you round the 1 up, it would get you 0.2.
Mm-hmm.
So we could say that that maximum point is around 0.18 if you're
Mm-hmm.
okay with that estimate. You could also totally like take a screenshot and use this too because it's like it's hard to see the
Yeah.
numbers. So we have the midline, it's at 0.05, and then the maximum point is about 0.18. Now, if I want to find out what distance, what can I do? I mean, what is distance right here from the midline to a peak? So I know that the height is 0.18 right here, and the
Mm-hmm.
bottom is 0.05. What can I do to figure out this length or this distance?
Mm. You measured it the in the x, right,
What was
axis,
that? You measure it in the x?
x y, no, x
Because this
axis.
here's x, and then this one's our y. So x-axis would be down here, like side to side. And I think we did that when we measured the period, was side to side.
Oh yeah. Mm,
That's okay if you don't know. Um, and then if let me, I could also show you back. Let's see if I go back to the slides to show you what we did, just as a little reminder. But like to find the period, I mean the amplitude, for example, here you remember I drew the midline,
mm-hmm.
and then I had to count like how high
Oh
it.
yeah.
And so let me go back to.
So you count how many squares? No.
Sometimes it could be the squares. The only problem is that this is like a very, kind of hard graph to read. So basically, if you can't count the squares, here's what you can do. Then let me type it out. You can subtract the maximum number from the midline. That's what you could do, and you could find that amplitude. So if I do 0.18, this one,
Mm-hmm.
minus 0.05. 0.1.
Mm-hmm.
That way you don't have to count anything, and it's kind of hard to count on this kind of graph because it's like the numbers are too small.
Uh-huh.
So try to check out what you get when you do that subtraction on your phone or calculator. So let me know what you get to see if I get the same thing.
It's 0.13.
Yeah, so this is going to be your amplitude. That's going to be your amplitude. And then you want to just type out like how you got that. Like the same thing. Again, you could take a screenshot,
Mm-hmm.
just explain it in your own words on what we like did to get this. And again, it's applying the same thing we did in class. The only thing is just that it's a little bit hard to read the graph and you have to make some estimates.
Mm-hmm.
So that's why you want to just zoom in and like try to do it from there. So that's how you get your A. And then for the rest of this, just try your best. And I could also just give you feedback. So just try to find what your B, C, and D is. Actually, if you're looking at this, Angelica, what would be your D term? What's the vertical shift? Let me also remind you on how we found that today.
It's like 4 point something. No.
So 4 point, like right here we have like for example this. So vertical shift is going to be a Y value, so it has to be on this.
Oh.
Um, and let me remind you on how we found that today. So for example, right here,
Uh-huh.
you remember what the answer was for the D term? How we found this one? Do you remember what it was?
5. No.
Yeah,
Negative 5.
yeah, that's right. So how we found that is, you remember that was the one I had a trouble drawing. But so step one is you draw your midline. Again, I can't see where this is at. Oh, I did it wrong. So
Just pretend it's 5.
yeah, so pretend it's 5. It's because I can't see it, but okay. So it's okay, I think that's pretty good. And basically what it is see how it's intersecting the y-axis at -5? That's
Mm-hmm.
your D. That's it. Like whatever the midline is intersecting the y-axis, that's
Mm-hmm.
the D term. So let's go ahead and go back to your graph. What would be your D term? What y value is your midline intersecting?
0.13. No.
0.13 was actually the amplitude.
No. 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 It's 0.05. No.
Yes. Yes, that is it. So your D term is where
Okay.
your midline is intersecting the y-axis. In this case, it's 0.05. That's right. So I guess you could also work on your B and your C, and then we could talk about that um, when we come back from break. Just try your best in getting in that draft, and I'll give you some feedback.
Okay.
Yeah, that was fun actually, even though it was a little bit complicated with the tiny numbers. It's pretty fun. Can't wait to see what you come up with.
So for B, I just measure the black thing.
So for B, you just measure the black thing. Oh, so for B,
It would be 4 point something, no?
so let's see. So B, let me just go back to our slides. So how we found B, and I'm also, by the way, gonna send a video,
Mm-hmm.
later on so you can review it. But how we found B was I had to use this formula. The period equals 2 pi over B. Step one is you had to first find your period. So that's the one where I calculated the distance between these two.
Mm-hmm.
And then what I had to do was use my x-axis as a ruler. Do you remember that part?
Yeah.
And then I had to solve like the
Mm-hmm.
whole steps, right? But actually, you don't have to do this again because you already did that. If you look back to your mini final, you already found the period is 0.00448 seconds. That is your period. So you found your P, right?
Uh-huh.
So I'm going to just remind you this is the formula. Period equals 2 pi divided by B. We don't have to put absolute value. Let's just write B. Now, period, you already found it. It's right here. You're going to substitute that. And then you're going to solve for B, and that's going to tell you what that B is.
Also, that when you simplify that, that's another way you can find B.
So actually for this one, it works like that because that little measuring tool helped you
Uh,
already do that without doing the same steps we did in class. So that's why it
uh,
saves you some time. So all you got to do to solve for B is you're going to take this, plug it in for P, and then you're going to do that cross multiplication
uh,
technique that I showed you. And you just try your best on it, and then I'll give you some feedback.
okay.
Yeah. So
Actually, I didn't know that because I was doing through the graph yesterday, and I was having a hard time. But
okay. Yeah, yeah, okay. So you have some way to get started now. We already got your A, you got your D. You're gonna work on getting your B, and then we'll see what you get with your C. Your C.
okay,
Okay, awesome.
okay. Thank you.
Cool. Am I seeing you later? Is there Latinos Unidos?
Oh yeah, I forgot.
Yeah, you're like working up until it's a 3, right? It starts at.
Yeah.
All right. I'll see you soon. Then I'm gonna take a.
Okay. Bye.
Bye.